Hello, my name is Bart. I work for JEOL as an applications specialist, and today I would like to demonstrate how to use PyJEM to create a graphical user interface application. We will be working remotely on a real microscope. We connect to this microscope with a remote access connection. And here we want to create an application that is going to control whether the beam is parallel or not. So we want a simple graphical application that is able to capture the state of the beam. I mean here the CL3 value or the beam spread. And then this application should be able to set this value on demand. On older microscopes, this may be used to create a parallel beam button, a button that you click on in order to very quickly set parallel beam conditions. How can we do it with PyJEM? Well, let's write a simple script. We will be using just Notepad, nothing fancy, just a simple Notepad, in order to edit this script. The assumption is that you already know a bit about Python, you know a bit about programming, and you have already watched the video explaining how to install PyJEM on a JEOL computer. Okay, let's get on with it. We have Notepad open. In this case, the first thing that we want to do is we want to import tkinter. Tkinter is a very simple graphical library. It ships with Python. You don't need to install it. There are no licensing issues attached, so everyone is free to use tkinter for commercial or non-commercial applications. And the other thing we want to do is we want to import the TEM3 class from PyJEM. Okay, so we need these two imports. The next thing to do is to create a lenses object. Let's call it just lenses, and this is TEM3 lens3 class object. And then we also need a window. Let's just call it a window, and this is tkinter.tk class object. Then we need some form of storage. We need a container that will store the CL3 value for us. Let's make it a class. So let's define a class, and let's call it stored value. And then this class needs a constructor. So it's a special function that is always invoked when when an object of the instance of this class is being constructed. 1, 2, 3, 4. So I'm using 4 spaces here to indicate where the indentation starts. So 4 spaces here, 4 spaces here, and let's say that the stored value class will have just one attribute, and this will be the value. And let's set the default value to 8000. So this is the default DAC value that we want CL3 to have. This class also needs a method to capture CL3. So let's define it. Let's say this will be getCL3 method, and all this method does is it assigns to the value attribute the product of the getCL3 method of the lenses object. And then similarly we need we need a method that will set CL3 value, and in this case this is lenses, so that's our object, set CL3 and then self value. So you see, all this class does is either it captures CL3 or it sets CL3 value and then it stores it. This is all it does. The get CL3 and set CL3 methods of the lenses object are described in the PyJEM manual. So I encourage you to read the manual to understand exactly what these methods do and what sort of arguments they require. Okay, then let's create an object of the stored value class. So this is our container. And then we need two buttons in the window. The first one will be the get button. And this will be a tkinter button object. Let's say that the text inside will be get as parallel, and this will, clicking on this button will invoke a command. I am going to use the lambda expression here to call the CL3 value get CL3 method. There are other ways to do it, however I think that lambda in this case is probably the best approach. And then we need a set button. This is tkinter button again, and then here the text will be set parallel beam conditions. And in this case the command will be again lambda, and this is CL3 value set CL3. Okay, so we've got the container, we've got the buttons, then what else do we need to do? Probably we need to pack these buttons in a window and set button pack. All these commands do is they make sure that our get button and set button are properly displayed in a window. And then finally, just for fun, we can set the window title, and maybe let's call it parallel beam by PyJEM. Here we go, and then the final command, as usual in graphical applications, is basically tells the program, tells Python to enter the event loop and wait for user interaction. So that's it. A simple application like this should be enough to provide a button that either gets a button that gets and a button that sets the parallel beam condition. Now let's make sure that this works. Let's save this, and let's save this first as a text file. So test.txt. And then let's try to execute it. So I need Anaconda prompt for that, and I need to activate my PyJEM environment. Then I need to navigate to the directory where I saved my file. This is PyJEM test, and I need to rename my test.txt to test.py. Okay, and then I have to run the script just by typing python test.py. Okay, so you see what is happening. I got a window here It's indeed called parallel beam by PyJEM. Let's see whether this works. So let me open the beam valve first. We can see that the beam appears. So this is a real beam. You see, I am able to change the beam spread. I am also able to move the beam. So this is a real microscope. Okay, so first let's find parallel beam conditions. We can do it using the objective lens wobbler. When we turn on the wobbler, we can spread the beam and find conditions where the beam diameter no longer changes. For example, here. I can switch off the wobbler, and in our application I can click on the Get as Parallel button. This is done now. And let's confirm that the application works. Let me make the beam smaller, so I condense the beam, and let me click on Set Parallel Beam Conditions. And you see that the beam is instantly spreaded to the same diameter that we stored using the Get as Parallel button. If I try to make the beam larger, again somewhere here, so it spreads, it covers the whole fluorescent screen, and again if I click on Set Parallel Beam Conditions, my beam becomes parallel again. So this is a very simple demonstration of how to use a very simple, natural, logical piece of code to create a graphical user application that you can use on a real microscope. This is how easy it is to use PyJEM to prepare graphical applications, especially simple graphical applications that make life easier. Although modern JEOL systems provide parallel beam button, like here in TempCenter, older systems, for example 1400 or 2200, they lack this button, and this is how you can create it and add additional functionality to older microscopes, to the previous generation of microscopes, using Python and PyJEM together. This example will be shortly posted on GitHub, so you will be able to download the code, run it, and see what it does on your own microscope. As usual, if you have any questions about this video, I would be very happy to answer these. Please contact me by email, or please contact your local JEOL representative if you require any further support. Thank you.